and I'll walk you through this in just a minute, but I'll show you this was bad proportion. This is what we're looking at right here. If I have a distance and I want to repeat that distance, because everything gets shorter the further away it gets, or smaller the further away it gets, there's a simple kind of method called the diagonal method, which I'll show you in just a minute. But it basically, if you could imagine this as, here we go. Now those are railroad cross ties. There's a way, yeah, tiles in the ceiling, you got doors or windows that repeat, and it's the same thing over and over again. What your homework is asking you to do, I guess I can show you this. So if you look right here, if you have a square, and this works both in perspective and it works orthographically. So if I have a square and I want to repeat that square, if I do it orthographically, I can put an X. What that X does is it helps me find the center. Then I can draw that center out horizontally to find the center of that line. That X gives me the center regardless of whether it's a square or a rectangle. So you can imagine if I have a rectangle and I need to find the center of that rectangle, or if I needed to find a midpoint down here, I can draw an X, and then that gives me the center or a midpoint. Okay? So regardless of whether this is a square or a rectangle, this will hold true. The diagonal method is focused on this diagonal. The reason why it's called a diagonal is this diagonal right here. And what that diagonal does is it goes through one corner, from one corner, through that midpoint, and then when it intersects a parallel line, that ultimately gives me that same division. And so I'll share with you in just a minute what that is. We're doing the same thing here, but it's in perspective.
This is really cool, but watch what Jared's doing. Really cool way of just repeating proportion over and over and over.
So what I'm gonna do, and I'll put my training wheels on just for the purposes of you. This is for you just to pay attention to. All this is in your handout, so you don't necessarily need to draw it. I just want you to pay attention. So I'm going to put a vanishing point there and a vanishing point there. Yes. Whoop. Whoop. Whoa. Oh. Interesting. It also this doesn't matter where I am relative to the horizon or vertical horizon line or horizon line. But what I want to do is I'm gonna start by just drawing what I think is a square surface down here. So I'm gonna try and employ my proportion. Y'all help me out. Is that a square? No. Tell me when you think I get to a square. I don't think you're right. That's a square right there. Okay, so what I am looking at, what I am trying to reproduce here is this distance. Let's just say that that's 2 feet in real life, and I want to repeat that 2 feet. I can't just take this and plug it right there because everything gets shorter as it goes away. So what I need to do is I need to find this midpoint. And to find that midpoint, I'm first going to put an X. Let me make this other green a little bit darker. So the first thing is I get the X. That gives me the midpoint of that surface. And if I take that midpoint of that entire surface and take it back to my vanishing point, so I'm going to draw that whole thing in, but really all I'm concerned with is this. And that's given me a midpoint. So this is the center of that surface. This is the midpoint of that line. And then what I want to do from here, I'll do this in red. I can choose either corner. I can either choose this corner or this corner. I can choose either this corner or this corner, and I'm going to go through that point and then find where it intersects one of those parallel lines. I can't remember which one maybe is a little bit more accurate when we talk about tolerances. But I'm going to go from this point through that point and intersect that line. There's my diagonal. That's where the name comes from. And that gives me that point right there. So if I carry that over from my left vanishing point, that is, and it looks awkward. I've just duplicated this distance back to there. Okay? So if I was building or stacking up cubes, which your homework is to build a fairly simple bookshelf, all my vertical lines for homework, your vertical lines are going to be vertical. And trust me, you will see some of this. It looks like it's a little awkward moving back. I'm going to try and make that front thing a cube. What's interesting is that my original construction, that diagonal method, I did it on a horizontal plane. I did it on that horizontal plane. You could do that same thing on this vertical face if you wanted to. This face right here in the front, you could repeat that same step and it would work. So it doesn't matter if it's horizontal or vertical. Let me come back to this and show you again. So one other thing that I did not mention is that the reason why there's an X in this first one is because why? That gave me the midpoint, right? That I was able to carry towards that vanishing point. It gave me that midpoint. Once I have that line, every time it intersects one of these vertical ones, I know that that's the midpoint. And so from there, all I have to use is the diagonal. So I don't have to create the green X again. All I have to do, that blue line, which every time it intersects one of my new lines, it's the midpoint. So from here, I can go from this point through that midpoint back up to here. So from this point through that midpoint up to there. And then I can carry this over from that intersection.
There's something inherently cool about the diagonal method. I don't know, for me, it's my warped, twisted mind, but I love doing the diagonal method. It's like easily repeatable, but it's kind of a, I don't know, it's like a construction that kind of flows out of itself so easily. It's kind of fun to do.
So I'm going to do it one more time, very quickly. I've just flipped my page over, but I'm going to do it on a vertical surface as opposed to a horizontal one, just to show you that it also works. And I'm going to do it with a proportion that is not a square. So let's just say that this is the proportion that I need. And I want to reproduce this moving back towards this left vanishing point. What's the first thing that I do? I'm going to put an X. What is that X giving me? Why do I need the X? Okay, so how do I find the midpoint? What was that? I'm going to go through this center point back to that left vanishing point, and that gives me my midpoint. Now, could I measure this and just measure out what that midpoint is? This is a trick question. If you know this, I'm going to bring some candy. Can I just measure this? Is this equal to that? Let me ask again, but do it over here. Is this equal to that?
Yes, because it's the midpoint.
It is the, in reality it is, but because everything gets smaller as it gets further away from me, then this is shorter than this one. So here's the trick part of the question. What about here? Well, here, that's not on a vanishing line. Remember how I told you that 2-point perspective, the reason why it's lying to us is that it's not vanishing up or down. So in fact, and again, I don't mean to confuse anybody, I could measure this because it's on a vertical. But the X method is a better way to do it. And that's the principle that we're teaching. Okay, so now what do I do? That midpoint is important to me. This is important to me. What's my other important point? Come on, a little bit louder. Bottom right corner or top right corner. I can go either way. Let's go this way. And this is our diagonal. So from here through there to hit that line, there's that same distance duplicated. I could again go from this corner through my new midpoint